Hello students, very good afternoon. This is Mayur S. More, your chemistry tutor. I welcome you all to JEE Chemistry, session number 5 for the ionic equilibrium. We had seen this chapter earlier. We have started this chapter maybe 4 sessions ago, right? We had seen pH, pOH, types of electrolytes, strong electrolytes, weak electrolytes. Then we had seen how pH and pH calculations are differ from solution to solution. Okay, so we had seen all of those types, and today we're gonna see what are salts, what are different types of salts, how their hydrolysis actually works. Okay, so we're gonna see all of that in today's session. Okay, so on that note, let's begin. I welcome you all to JEE Chemistry session number 5, ionic equilibrium. Okay, let's begin. So salts. Now what is mean by salt? First of all, what is your salt? See, salts, we know that table salt, NaCl, KCl, we've been knowing it, right? You already know that NaCl, then your KCl, then there are different types of salt like RbCl, then you got CaCl2. All of these are what? Salts, right? We already know that these are the salts. But if you ask me how to define it, then what is the definition of it? See, salts are ionic compound. Now we already know that all of these are, what is NaCl? Na plus Cl minus, KCl, K plus Cl minus, Rb plus Cl minus, calcium 2 plus 2 Cl minus. All of these are ions, right? And there are only two types of ions in this world, cation and anion, right? So basically salt is a combination of cation and anion, and you can say in other words is that salts are the ionic compounds, right? Because ionic compound are having cations and anions together. So salts are the ionic compounds formed when its positive part, what is positive part? This positive part, cation. When its positive part, which is cation, come from a base, and its negative part, anion, comes from an acid. Now, if you look at the NaCl, how do you think NaCl must have been formed? Your NaCl is actually formed by combination of your HCl plus NaOH. HCl plus NaOH together give you NaCl. So here Na plus and this Cl minus, they combine together to give you NaCl, and OH plus H, they combine together to give you water. So here this Na plus came from the base, right? So that is what they were saying. No, cations came from a base and anions come from an acid. That is how your salts are actually made. Even your KCl, if you look at the KCl, KCl is actually made from just okay. Yeah, so your KCl is actually made from KOH. Okay, KOH plus you can take, for example, suppose HCl only. So this is your K plus and this is your Cl minus. That's how you form the KCl, and the remaining part, which is your OH and H, that together form the water. That always happens in neutralization, as we all know, right? So that's how you form the KCl. So again, positive part, which is cation K plus, that came from the base from here, right? And HCl, what is HCl? An acid. Acid gave you an anion, base gave you an cation. Okay, so yeah, so that is how all of this are giving you this. Now see, salts may be taste salty. Now we know that, so you, what are you saying, sir? Salt generally taste salty only? Yes, salts generally taste salty only. That's where the name came, salt. Okay, but that is not necessary that every salt will always taste salty. The table salt that we consume in our daily life is salty. Otherwise salts can be bitter also, they can be stringent also, sweet also, and sometimes they might be tasteless also. Okay, depends on what kind of salt we are referring to. The salt that we are referring, or salt that we are consuming in our daily life, is actually Salt of strong acid and strong base. See, we consume what? We consume NaCl, right? NaCl is actually formed from NaOH base and HCl. Now, NaOH is a strong base, HCl is a strong acid. So, the salt that we form here is a salt of strong acid and strong base. Okay, so that is why it's a salty. If you're talking about the other salts, yes, they may be bitter, stringent, sweet, tasteless, like that. They could be different types of salt. Okay, now solution of salts may be acidic, may be basic, may be neutral. That is what we're gonna see in the upcoming slide. Solution of salts, whenever you put a salt into water, it might form an acidic solution, it might form a basic solution, it might be neutral also. It depends on the conditions. Okay, it depends on the condition. But fused salts and their aqueous solution conduct electricity and it undergo electrolysis. We all know that. We all knew this right from our 9th standard or 10th standard, that fused salts, that means what? NaCl in a melted format, NaCl in a liquid form, that is fused NaCl, or it's an aqueous solution, that means NaCl dissolved in water to give you Na plus aqueous plus Cl minus aqueous. So this solution also conduct electricity, it undergo electrolysis also, and fused salts also, obviously. Okay, and lastly, salts are generally, I'm saying generally, salts are generally what? Crystalline solid. That is what I'm showing you here. See, this is your crystalline solid. The one you are seeing here, this is your crystalline solid. That's how they are packed. Okay, they are compactly packed like that. That's how your crystalline solids are actually. Okay, chalo, moving ahead with that now. Now, classification of salt, how salts are being classified. Okay, how salts are being classified. See, there are 4 types of salt. One is simple salt that we just saw, right? We just saw the simple salt. What is simple salt? NaCl, KCl, the salt which have been formed from the combination of acid and base. It's called as a simple salt. Double salt basically is the combination of 2 salt, as the name suggests. Then you got what? Complex salt. Complex salt is basically a complex mixture. Complex salt is nothing but a complex mixture. And mixed salt again is a combination of 2 or 3 different types of salt. Okay, we're gonna see all of that as we progress ahead. Okay, so starting with simple salt. What is our simple salt? See, the simple salts, these salts are actually formed by the neutralization process between acid and base. That we already know. We know it, right? That every salt is actually formed by neutralization process between acid and base. Now there are 3 types. Now there are 3 types of these salts. First is normal salt. Now what is your normal salt? See, the normal salt is actually formed by the loss of all possible protons. Normal salts are actually formed by the loss of all possible proton. I would say replaceable H plus ion. For example, let's look at the NaCl. Now, how do we form the NaCl? NaCl is actually formed by a combination of HCl plus NaOH. So what does NaOH do? NaOH releases the OH minus ion, and OH minus actually abstracts the H plus ion from here. It abstracts the H plus ion from here to give you water, and this gives you NaCl. Okay, so it has abstracted all the protons which are present here. Okay, now you say, sir, how you are saying all the proton? There's only one proton here, right? There's only one proton. That's fine. But let me give you another example now. Let's take the example of H2SO4. H2SO4. Now your H2SO4 has 2 protons, right? It has 2 protons. It is combining with NaOH. Now obviously, if there are 2 protons, we need to take 2 NaOH only. 2 NaOH will give me 2OH minus. 2OH minus will abstract both the H plus ion, 2H plus ion, and this together will give you 2H2O, right? Plus it will give you what? Na2SO. So basically Na2SO4 is a salt which have been formed by combination of, I would say, by combination of loss of all possible proton, or I would say combination of all replaceable H plus ion from the acid on reaction with the base. That's how you form the Na2SO4. So Na2SO4, K2SO4, NaNO3, calcium phosphate. How do we form the calcium phosphate? Pa3PO4 2. It must have been formed from what? Calcium phosphate, right? So 2H3PO4, right? 2H3PO4 plus, not actually 2, calcium hydroxide. So this will give you 6OH minus. 6OH minus will combine with 6H plus to give you 6H2O. Okay, and this 3 calcium and this 2 phosphate, they will combine to give you calcium phosphate. So you do not have a single proton here. You do not have a single proton. Basically, this normal salt, whenever they are reacted with water, they do not release, they don't release H plus ion. They don't release even a single H plus ion because they don't have a replaceable H plus ion, or I would say they do not have a ionizable hydrogen. Having an ionizable hydrogen is actually a sign of acidity. Having an ionizable hydrogen is a sign of acidity, right? If you don't have an ionizable hydrogen, that means it's not an acidity. Okay, now, so all of these compounds have been formed when base abstract all the protons from your acid. That is what is called as normal salt. Okay, now what is the next? Acid salt. What are your acid salts? Acid salts are the salts which are formed by incomplete neutralization of polybasic acid. What is mean by polybasic acid? Let me show you here now. See, let me rub it down so that we will have at least some space there. Okay, polybasic acids. Poly means what? Many. Basic means they can react with many bases. That means having many H plus ion. Having many H plus ion. Many means what? More than one, that's it. Your acid will not have 20, 30 protons like that. It will be having only more than one, just more than one. More than one H plus ion. That's it. More than one H plus ion would be called as polybasic acid. For example, H2SO4. Now, H2SO4 can release, it can release 2 H plus ion. It can release 2 H plus ions. Okay. Now what is the difference between this normal salt and this acidic salt? Now let me tell you this thing. The normal salt, what happens? Your base will come from here. Any base, whatever base it is, this base will give you 2 OH minus ion, and it will take both these protons together to give you 2H2. and whatever salt you get, that salt will be your normal salt. Okay? That is what the normal salt is all about. Now the one we are referring here is what? Here the salts are actually being formed when your acid is releasing 2H plus ion, okay? But out of which only one H plus ion will be absorbed. See, H plus, another H plus, and another sulfate. Okay. Now your base will come. Suppose the base that you're using is suppose NaOH. Okay. It will give you Na plus and OH minus. So this OH minus and H plus will combine. That will give you water, right? Now you got an anion. This anion is having 2 minus charge, right? That means it should be balanced by 2 plus charges. Out of those 2 plus charges, 1 plus charge will be given by this H plus, another plus charge will be given by this Na plus, and you will get what? NaHSO. So this is your what? This is your acidic salt. Now you would say, why it is acidic salt? Because when you try to dissolve this into water, it will give you what? It will give you Na plus plus H plus plus SO4 2 minus. So whenever you try to dissolve acidic salts into water, it gives you H plus ion, and that H plus ion is nothing but what? It's acid, right? We know that H plus ion, it's a phase of an acid. Just as OH minus is a phase of a base, similarly H plus ion is a phase of an acid. So this particular compound, it reacts with water to release H plus ion. Now since it can release H plus ion, what do we call it as? It called as acidic salt, because whenever it was reacted with a base could abstract only one, or I would say base which could not abstract all the protons from it. You can also call it as a incomplete neutralization. That is what the word we use here, right? The salts formed by incomplete neutralization of polybasic acids. Such salts contain one or more replaceable hydrogen atom. Okay. For example, NaHCO3, NaHSO4, NaH2PO4, Na2HPO4. Now all of this compound, you will always find them releasing at least one proton. For example, NaHCO3. Your NaHCO3 will be ionized as Na plus H plus CO3 2 minus. Similarly, NaHSO4 I just shown you here, right? So that is the way your acidic salts are. Okay, that's how the simple salts have been classified: acidic salt, normal salt. And lastly, we're gonna see what? Basic salt. But before moving to basic salt, let me tell you one more point about acidic salt, is that above salts, when neutralized by base, they form a normal salt. So this NaHSO4 is acidic salt now. If you want to neutralize it, it can be neutralized. There is a scope of neutralization. Why? Because the neutralization which happened earlier wasn't a complete neutralization. It was a partial neutralization. So as it releases Na plus, H plus and SO4 2 minus. Now you can bring in the NaOH, which would release the OH minus and Na plus, right? So this H plus, OH minus, they will combine together to give you water, and Na plus, SO4 2 minus. All of them will give you Na2. And Na2SO4 is what? Na2SO4 now is a normal salt. See, K2SO4, Na2SO4. I showed you earlier, right? So acidic salt, when reacted with a base, they give you normal salt. Okay, so that is what. Secondly, let me tell you one more thing. The pH of normal salt is 7. I would say the acidity or basicity of a normal salt is 0. Normal salt solutions are neutral. Acidic salt solutions are acidic. That is why we call them as acidic salts only, right? So moving ahead. Now the last, basic salt. Now you must have understood by this name only. Basic salts are the salts which on dissociation, or basic salts are the salts which when dissolved in water they give the basic solution. In the last case, when we had seen the acidic salt, there was what? There we had seen the acids, the polybasic acids have been neutralized partially. That means there was some of the H plus ion was still left there. Similarly, here the incomplete neutralization, here the incomplete neutralization would be happening for polyacidic bases by the acids. So there would be at least 1 or 2 OH minus extra with the basic salts. So again, that is what the definition says. The salts formed by an incomplete neutralization of polyacidic bases are called as basic salts. These salts contain, as I told you, 1 or more hydroxyl groups with it. For example, look at this ZnOHCl. So suppose your Zn hydroxide, which has 2 OH minus, okay. Now obviously it gives you Zn2 plus 2 OH minus. Now it is reacting with HCl, single mole of HCl. Single mole of HCl will give you what? H plus Cl minus. Now this H plus would react with a single OH only, right? It will react with a single OH minus only to give you water. One more OH is written there, Cl is there and Zn is there. Now the cation Zn2 plus should be combining with 1 OH minus and 1 Cl. That is how ZnOHCl is all about. When you try to dissolve this in water, what do you get? You get Zn2 plus, then you OH minus plus Cl minus. Now this OH minus obviously is what? It's a phase of a base, right? So it's a basic. That is why solution of basic salts in water is always basic. Okay. Now there are many examples like this: ZnOHCl, MgOHCl, ApOH2Cl. Now how you must have formed ApOH2Cl? This must have been formed like this. FeOH3 must be reacting with HCl. Now here, out of this ApOH3, one OH must have reacted with this H plus ion to give you water, and other OH are still attached with Fe only, FeOH2 and Cl. That is how you form this kind of salt. Now again, these above salts, when neutralized by acids completely, they form a normal salt, right? So your FeOH2Cl, if I try to react it with the 2 mole of NaOH, what would it do now? Oh, sorry. Yeah. 2 mole of HCl. So what will happen? This 2 OH minus and this 2 OH plus will give you 2 water, right? And apart from that, you get 2 Cl minus and this FeCl. That will give you FeCl. Now your FeCl3 is what? It's a normal salt. It's a completely normal salt. That means its solution would be what? Its solution would be completely neutral. So that is how all of these salts are being classified. Okay. So we had seen simple salts being classified as normal salt, acidic salts and basic salts. Okay. So I hope you must have understood it pretty well. Okay. Chalo, moving ahead with this. Next part is double salts. Now what is double salt? As the name suggests, double salts, right? So these basically are the addition compounds. they are addition compounds formed by the combination of two simple salts, which are termed as a double salt. For example, see, these salts are being made by how? How? You just take the FeSO4 solution. Okay, so this is FeSO4 solution. Okay, in that, and you take another solution, NH4 2SO4, right? Now you do what? You mix them together. You mix them together, then you get the another salt, this salt. So this salt, then you heat it for some time. Okay, then all the water will get evaporated, and whatever part you get at the bottom, whatever part you get the bottom residue, that is your what? That is your FeSO4 NH4 2SO4 6H2. That is called as a double salt. That is your ferrous ammonium sulfate. It's a combination of iron sulfate, ammonium sulfate, and the water. That is basically double salts. They are actually formed by the combination of two different simple salts. Okay, then you mix it together. Then excess of water, you keep it for some time on heating, where excess of water gets evaporated, and whatever remains behind residue, that is your double salt. Similarly, alum, K2SO4, Al2SO4, both of them have been mixed together. The solution have been mixed together. Water is being allowed to evaporate. Whatever remains behind is what? Is a double salt. That is how the alums have been formed. Okay. Now one more thing. The above salts, whatever salts you are seeing here, that is ferrous ammonium sulfate, alum. Then you also have a solution called carnallite, KCl MgCl2 6H2. That is called as carnallite. Okay. This is also a double salt. So all of these double salts, they are stable in solid state only. They are stable in solid state only. What do I mean by that? As soon as you dissolve them in water, they will furnish all the ions. They will furnish all the ions from which they have been made from. Basically, you can detect how many different types of ions your double salts are being made from. Or I would say the aqueous solution of your carnallite or aqueous solution of your double salt gives the test. Aqueous solution of your double salt gives the test for constituent ions. Okay. Now there is a difference between double salt and coordination compound. Coordination compound doesn't do like this. Double salt does in this way. Okay. But we're gonna see that in the coordination chemistry chapter. Okay. But for the time being, double salt, whenever you dissolve it into water, whatever ions they have been formed from, they will give the test for all those constituent ions. For example, this carnallite, you can see here, when you dissolve this into water, you get what? You get K plus, you get Mg2 plus, and you get 3Cl minus. So if you perform a qualitative test on it, you can get the test for K plus, you can get the test for Mg2 plus, you can get the test for 3Cl minus. So basically they just get decomposed. I'm not saying decomposed, they're actually getting dissolved. Okay, but what I'm saying decomposed because they just get separated from each other. Okay, now that happens in water because water is having a very high dielectric constant. Okay, because of which water is able to dissolve them. But as soon as the water gets evaporated, all of these ions, that means K plus, Mg2 plus, Cl minus, all of these ions will combine together to give you again a carnallite back. Okay, that is what I was saying. These salts are stable in a solid state only. They are not stable in any other phase. As I'm saying, when dissolved in water, it furnishes all the ions present in the simple salt from which it has been constituted. And lastly, as I told you already, the solution of a double salt, shows the properties of the simple salts from which it has been constituted. That means, see, you have a K plus here, you have a Cl minus here, right? Now KCl is a simple salt. I would rather say SS, simple salt. MgCl2 is also simple salt, SS. Okay, so if you dissolve KCl into water, you can get the test for K plus Cl minus. When you dissolve MgCl2 in water, you can get the test for Mg2 plus and Cl minus. Similarly, when you combine all of this together, which is the double salt carnallite, and when you dissolve it into water, you get the test for K plus Mg2 plus Cl minus. So ultimately, you get the test for a simple salt only, right? That is how the double salt actually behaves. Okay, chalo, moving ahead with this. See, as I told you, potassium sulfate, K2SO4, is simply mixed with aluminum sulfate along with water. Then that water is allowed to evaporate. Whatever remains behind, it combines together to give you what? A potash alum, a colorless crystalline solid. Similarly, carnallite, KCl, MgCl2 combined with water, again evaporation happen here, you get carnallite, naturally creating a double salt. This double salt is been created naturally. In fact, this is also a natural double salt. Okay, that is how the double salts are actually made. Okay, I hope I was able to clear what double salt and simple salts are. Okay, chalo, moving ahead. Now the complex salts. Now what is mean by this complex salt? Complex salt. See, these salts, they form by combination of simple salts or molecular compounds. Now combination of simple salt also gives us double salt, right? Combination of a simple salt also gives us double salt. But in a complex salt, sometimes you have a molecular compound only. So just by combining molecular compounds with a simple salt, also sometimes you get the complex salt. For example, FeSO4. Here, FeSO4 is combining with KCN to give you K4FeCN6. This compound, if I show you its structure, it actually looks like this. Fe. What is happening? Cyanide, then you got the cyanide. Here also you got the cyanide, and here also you got the cyanide. Okay, so that is FeCN6. Your iron overall charge is having a -4. Okay, that -4 is counterbalanced by K4. So you have a 4K plus there, 4K plus 4 minus here. That is how you form the K4FeCN6, a complex salt. Okay. Difference between complex salt and double salt. What is the difference? In double salt is a combination of 2 or more simple salt only. Whereas in a complex salt, it can be a combination of a simple salt or combination of a molecular compound also. Now here in both the cases, this is also simple salt SS. This is also simple salt SS. Okay. Here cobalt sulfate. Now cobalt sulfate is what? Cobalt sulfate is a salt SS. What is ammonia? Ammonia is a molecular compound, right? It is not a salt now. It's a molecular compound. So combination of these give us what? Complex salt. Now understand the difference between double salt and complex salt. Double salt, whenever your double salts are being dissolved into water, you get all the constituent ions as separated. That means you can test for all those constituent ions together. But here, whenever you try to dissolve K4FeCN6 into water, you can get the test for K plus only, for K plus, and this FeCN6, FeCN6 4 minus. Basically, your ion here is in Fe plus 2, but you cannot detect it. You can't detect it because it has gone into this coordination sphere. It has gone into this coordination sphere. Now you don't know whether your ion is in plus 2 or if it is in a plus 3 or whatever it is. It is just associated with this coordination sphere, and you can only come to know about the K plus. This you can detect it. This you can detect it. Obviously, chemically by performing a chemical experiments, okay, but you cannot detect the Fe2 plus. That is the property of a complex salt. That is the property of a complex salt, which is different than your double salt. See, that is what I was saying. So they are stable in a solid state as well as in solution. Now that's the difference here. They are stable in solid state as well as in solution. They are stable in both the cases. Okay. As far as double salts are concerned, what was the double salt thing? In double salts was stable only in a solid state. As soon as you try to dissolve them into water, what was happening? As soon as you try to dissolve them in water, they get dissociated completely. But for a complex salt, it doesn't happen. Complex salts, they are stable in solid state as well as they are stable in solution. Okay. So as I told you, on dissolving in water, it furnishes a complex ion. On dissolving in water, it furnishes a complex ion. This is the complex ion. This coordination sphere is what is nothing but the complex ion. Okay. The properties of the solution are different from the properties of the substance from which it has been constituted. That is what I was saying. Your ion was plus 2 in a plus 2 here, okay, and KCN was in a K plus CN minus. So here you can check the test for CN minus also, K plus also. You can get the test for K plus as well as Cl minus and for Fe2 plus. But as soon as it forms this coordination compound, you cannot test the Fe2 plus. You cannot test it for the cyanide minus also. You cannot test it for the Cn minus also. Okay, that is what the difference between double salt and a complex salt is all about. Okay. So lastly, the mixed salt. What is the mixed salt now? See, mixed salt is what? It is the salt which furnishes more than one cation or more than one anion whenever dissolved in water. Whenever they are dissolved in water, they give more than one cation or more than one anion. For example, CaOCl2. This is also called as a bleaching powder. This is also called as bleaching powder. So CaOCl2, whenever it is dissolved in water, see, that is how actually CaOCl2 is. CaOCl and Cl. So when you dissolve, what do we get? Whenever you dissolve this into water, you get Ca2 plus OCl minus plus Cl minus. See, you have got one cation here, one cation and two anion. So this salt is giving you more than one cation or more than one anion whenever they are dissolved in water. Similarly, NaKSO4. I would say different types of cations or different types of anion. You were always getting more than one cation or more than one anion, but most of them have been of same type. Here, these are different types of cations. See, you get Na plus, you get K plus, and you get SO4 2 minus. So these are the two different types of cation. Here you are having two different types of anion, right? Lastly, NaH4 HPO4. Whenever you dissolve this into water, you get Na plus, that's a one cation. You get NH4 plus, that's one cation, and HPO4 1 minus, that's one anion. That is how you get different types of cations and anion. That is how your mixed salts and all the types of salt is all about. Okay, so I hope you must have understood this pretty well. If you have any doubt regarding this, you can ask me in the comment section. I will obviously try to answer it. Okay, and for more such video, please like this video, comment on it, subscribe to Practical Live on YouTube. Okay, you can also download our app from a Google Play Store or from Apple Store. You can subscribe to it, you can log into it. You can check the different courses. We have a courses in a Vedic maths, coding, chess, robotics. We have a course running in a Python also, pre-Python also. So you can check all of those. Okay, but for that you need to download our app. Okay, so that's it from today from my side. Bye bye everyone.